Class, welcome back to XY Lecture 101. Now I will discuss about electrical power. So what is electrical power? So when we say electrical power, it is something to do with electricity. Electrical power, it is the rate at which electrical energy is being used. So power is expressed in the terms of the watt, which is equal to 1 joule per second. Or electrical power is equal to energy over time. So, number one question, what are the factors that affect electrical power? So, the factors that affect electrical power are the following. First one, we have current or I. Second one, we have resistance or R. And then the third one, we have voltage or V. So those are the factors that affect electrical power. The second questions we have, what are the equations for electrical power? So we have three equations for electrical powers. First equation we have, power is equal to voltage times or multiply current, or E is equal V times I. The second one, we have power is equal to current squared times resistance, or power is equal to I squared times R. And the third one we have, power is equal to voltage squared over resistance, or P is equal to voltage squared over R. So I will giving you tips or reminders in solving some problems involving electrical power. Number one, you have to analyze and comprehend the problem. Again, you have to analyze and comprehend the problem. Second one, you have to determine the known quantities and unknown quantities in the problem. The third one, you have to select or use appropriate equation to the problem. And the third one, or the last one, do not forget the unit of every variables. In the third question, we have, what are the units of the variables in the electrical power? So the unit for power is watt, and then the unit for current is ampere or A. Again, ampere, A. And the unit for resistance is ohms. And the unit for voltage is volts. Again, the unit for voltage is volts. Now we are going to solve or compute some problems involving electrical power. So we are going to use GRESA method. So what is GRESA method? So GRESA stands for G is for given, R is for required, E for equation, and then S is for solution, and then A for answer. So number one problem we have, find the power consumed by a 240 ohms light bulb when the current through it is 0.6 ampere. So what are the variables given in the problem? So the variables given in the problem are the following. So we have resistance and current. So given, so we have resistance is equal to 240 ohms, and then current is equal to 0.6 ampere. And then the required is power. So we are going to use, what equation are we going to use? Equation number 1, 2, or 3. So we are going to use equation number 2 because current and resistance are given in the problem. So our equation is P is equal to I squared times resistance. So let's substitute the values given in the problem. Solution. So power is equal to what is the value of current? 0.6 ampere squared. And then times, what is the value of resistance? 240 ohms. So, we have to multiply 0.6 ampere to itself, or 0.6 times 0.6 is equal to 0.36 ampere times 240 ohms. So what is the product? So the product is 86.4 watts or 86. So this is the final answer. Did you follow? Okay, number 2, we have the power dissipated by electric appliances is 60 watts. What is the current flowing through it if it's connected to a power source of 220 volts? So what are the variables given in the problem? So the variables given in the problems are the following. We have power and voltage. So what equation are we going to use? Equation number 1, 2, or 3? So we are going to use equation number 1 because power and voltage are given in the problem. So let's solve. Given, so we have power is equal to 60 watts, and then voltage is equal to 220 volts. So always remember that the standard voltage here in the Philippines is 220 volts. And then the required is current. And then our equation is P is equal to VI. But we are going to derive this formula. So we have to write voltage at the vote denominator, at the vote side, to cancel out the voltage. So our formula for current is equal to P over V. Or just use magic triangle. Magic triangle, we have this one. Electrical power, and then voltage and current. So if you are looking for electrical power, just cover it, and then this will be the equation. And then if you are looking for voltage, that will be the equation for voltage. And then if you are looking for current, that will be the equation for current. Okay, our solution is equal to, let's substitute the values given in the problem. So what is our power? 60 watts. And then what is the value for voltage? 220 volts. So what is the answer for 60 watts divided by 220 volts? So the answer or the quotient is 0.27 ampere. Again, the answer is 0.27 ampere. Okay, the last problem we have, how much power is developed by an electric motor which draws a current of 4 ampere when it is operated at 240 volts. So how many horsepower is this? So let's analyze the problem. So what are the variables given in the problem? So the variables given in the problem are current and voltage. So since current and voltage are given in the problem, we are going to use equation number 1. So what are the given? So our given in the problem are I is equal to 4 ampere, and then voltage is equal to 240 volts. And then what is our required? Required is power. And then our equation is P is equal to V times current. So our solution, so let's substitute the given values in the problem. P is equal to, the value for voltage is 240 volts. 240 volts times, what is the value for current? 4 ampere. And then answer is equal to P is equal to 240 volts times 4 is equal to 960 watts. So this is our power. Power is equal to 960 watts. But we are going to convert 960 watts in horsepower. So always remember that in 1 horsepower is equal to 746 watts. So let's convert. So 960 watts, 60 watts. So we are looking for horsepower. 1 horsepower is equal to 746 watts. So cancel out watts. So 960 divided by 746 is equal to 1.3 horsepower. It means that in 960 watts, there is 1.3 horsepower. Again, in 960 watts, there is 1.3 horsepower. That's all. That's for all, class. Thank you for watching. I hope you learned something from our discussion. So if you have any questions, clarification, you may comment below. And then you can also suggest our next topic to be discussed in this channel. Don't forget to subscribe, like, and share this video. Thank you so much.